All right, welcome everyone. We have a bunch of new people today on the call, and we're going to talk about PCI LMT in a second. But before that, let's do some quick introductions. I will name the names as they appear on my screen, so please do like a couple of seconds of who you are and where you're from. First one is Leland Peng.
Yeah, this is Leland Peng. I'm from Meta in the IDC data center. Work as a system integration engineer. My main focus is on the PCIe related topics. Thanks.
Thanks, Alan. Next up, Tim Ansel.
Hi, I'm Tim Ansel. I'm here mainly as an observer on a personal interest, although I do work at Google. I'm very interested in PCI Express and have been playing with Facebook and Google tools recently.
Okay, thanks, Tim. Mark Jeffries.
Yeah, I'm a hardware qual engineer at Google, have been using different PCIe lane margining tools to try to qualify our PCIe devices and would love a better tool. So that's why I'm here.
Thank you, Mark. Hua Tang.
Hi, I'm Hua, first time here. I'm from Google working on the ASIC team. Main responsibility nowadays is help bring up our chip, focusing on the PCIe area. Yeah.
Thanks. And Venkat Ramesh.
Hey, this is Venkat from Meta. I work the test automation infrastructure team here at Meta. Previously, I was part of the NPI team and worked on various storage and accelerator initiatives. So here, in general, joining the work stream. Thanks.
All right. Thanks, everyone. I hope I didn't miss anyone. So, Dan, who is starting on the LMT discussion?
So I thought what we could do here, the folks at Google have seen the Meta presentation that was put together. Wall has a presentation as well. I don't know that you've got it sanitized to a point that you could share it, though, so I don't want to put you on the spot, right? If you do, fantastic. We'd love to have the input. If not, that's okay as well. But I think what I wanted to do is have the Google folks have an opportunity to ask questions and whatnot concerning the Meta tool. But it might be good to do a quick rehash of it because I don't know that everyone's had a chance to take a look at it yet. Referring to the slides, actually. Do we have the right folks on the call for that? I'm looking.
I don't think we do, then, because Satish is not on the call and Francesco is on PTO.
Okay, well then that's a problem.
I know. Let me see if I can ping Satish.
Okay, yeah, see if you can get a hold of him. He did ping me very, very late last night saying he wasn't going to be able to make it, but I did think that Francesco was going to be here. If not, what we can do is we can pivot and we could show the Google tool, but I think that we probably need the input from Meta.
Yeah, I don't know if anybody from the Meta side can take a pass. I was not on the call where Francesco and Satish presented LMT, so I don't want to. If nobody steps in the next 5 seconds, let's just pivot back into Hua's presentation, if that's okay.
Okay, sounds good. And try to ping either Satish or Francesco if you can, and if not, it doesn't happen. But why don't you take it away then? We're trying to gather the right folks.
Sure. Let's see. Oops. Do I just? This is a Zoom, huh? Do I share screen?
You do.
Okay.
Yeah.
There we go. Share. Let me know if it's coming up or not.
It looks
Yep,
beautiful.
it's working.
Yep, we can see it.
Well, I cannot see it on my Zoom window, but okay, I'll take your word for it. Okay, so this is an overview of my LMT, lane margining tool. First of all, just disclaimer. I assume kind of you already know what the PCIe 6 lane margining at receiver, what it is. You know, the background, I'm not gonna cover that here. Well, knowing this is not this should not be understated, right? Okay, so this tool was kind of implemented by me according to the spec to mainly serve my own needs as I would bring up our own PCIe, our team's chips PCI interface. You know, I hope my needs like it's shareable with others, but kind of I'm just doing this on my own out there. I haven't synced up with many of the experts in this area yet. Okay. So my approach, my needs is like in two use cases here. One is in system production testing. I think that the lane margin as receiver feature is gears towards that. So the requirement there is you want to get a pass-fail indication, right? And then you want to say set a single margin offset per direction of the eye, and set a criteria, you know, how many the dwell time or the error count maximum, and it'll give you a pass fail. And you want to cover all the interested, you know, receiver points in the whole system. Because this is only used in a system test environment, and it's not for like a ATE type of usage. You need to have a link up enumeration in order to use this feature, right? And you want to reduce the test time, like by parallelizing all the links, and have a reasonable dwell time. And another use case is potentially for characterization. And usually that's done with, you know, the PCIe 5 vendor specific tools. But we do want to correlate that with the lane margining tool, right? For the purpose of setting the pass-fail criteria in production testing. And also for failure analysis, right? When you see a failure in production testing, you want to zoom in to the failure point and maybe do a sweep to get the kind of the eye diagram as usually the SerDes vendor tool can provide. Okay. So any question on that?
So basically, this is kind of the same as the tool Satish and Francisco developed. I think both companies converged on this tool.
I think, yeah. So good to hear that. That's one of point out that because my my needs is shareable with others, right? So that's good. Dan, you have your hand up.
Yeah, I did. It took me a while to figure out how to raise it. The question I had for you is for the meta version of the tool. I haven't seen the code, but based off discussion from last week, I think it was a wrapper around PCIe utils. And then they were using basically that utility to invoke sort of the built-in lane margining feature of PCIe 5, I guess it is, that they added that, right? Or maybe it was 4, I don't remember. It's been a while though. The question I had for your tool, are you using any proprietary vendor tools? Are you using like AMD Express IO, C scripts, anything like that? Or is it just straight vanilla Linux utilities right now?
Yes, I think we converge on that also. I'll get to that.
Okay.
Yeah.
If you got slides, sorry, I didn't know.
Okay.
Although on that point, quick point, then I do think in talking with Francesco and Satish, the LMT tool that is currently being used uses LSPCI to work around the caching that PCI crawler has. So just to be clear, I think it's going back to LSPCI.
Okay, and that's
Yes.
where the bus topology gets stuck.
Okay.
Right?
So,
yeah, I ran into that.
So since it is brought up, okay, the PCI utils library is the underlying layer to support the LSPCI and setPCI, those tools. So we're talking about the same thing here, and that's what I use too. Okay, I think that this is, I guess, it's no brainer that everyone will because it's a standard tool that give you all the capability. It's just a top layer to operate sequencing the lane margining.
Question from
yes.
Rajat.
Yeah. So is there from a setup perspective, hardware setup perspective, there is no additional cards required, or you just have a regular PCI Express card or equivalent?
This is like a system testing. Basically, it's when you have device talk to device, right? You enumerate the PCIe bus, which you have a host running operating system. In this case, it has to be a Linux because we're using the PCI utils. Then you can conduct this test and get the signal quality of all the links on the PCIe bus.
Okay,
Does it make
but
sense?
you still need the scope set up to probe the bus.
Okay, maybe I'll go through. I have like a few more slides,
perfect.
maybe two,
Okay.
three more slides, and then we can hold up these questions
Sure.
after that.
Sure.
Sure. A better idea. Okay. Any other question? That's one. Okay. So
just maybe one quick comment since it was brought up. We do have some Microsoft folks on the call. PCI utils and setPCI actually are ported to Windows, so I believe they have full API compatibility, at least to the library.
Okay, good to hear. Well, I haven't tried it yet. On the proprietary.
Before you move on, just maybe one clarifying question, because this has come up last time we talked about this. This is about the environment in which these diagnoses are tested. If it's covered in your future slides, that's fine, but you're setting the context. We talk a lot about labs, manufacturing, and data center production environments. Is this applicable across all three of those environments?
Yes, I think I've deployed this tool in all environments already. Okay. I've used it in many cases.
Yeah, I'd be interested to hear if you have it covered about what makes the runs in each of these respective environments different and how it's parameterized. If we can get to it, that'd be very interesting.
Okay, yeah, I'll get to it. Okay,
great.
So, okay, so here, this is what it can do, but just a graphical representation. Basically, this is done in the characterization mode. You can grab all the links in the system. Okay, so for example, can you see my mouse cursor, or no?
Yeah.
You can see my mouse cursor. Okay, so basically, each of these group is okay. Over on the left side is the voltage. I put it, the I in the I direction. Like on the right side is the timing margin. Okay, and each bundle of these things are links on the link, and you can have multiple receiver points on the link. For example, in this case, we have the downstream port from the root complex, and you have one retimer. Okay, the upstream, downstream retimer port, and then you have the endpoint device. Okay, the gap here is like you potentially can have two retimer on the link, and I have like a replicated link of the same device in the system. So
I'm sorry, I apologize for interrupting. I was wondering if you could go into presentation mode. It's a little small in some of our monitors.
Okay,
Thank you, sir.
let's see.
Slideshow mode.
Slideshow mode, but that's
If
gonna.
you just click slideshow, yeah, right there.
Yeah,
That should
it's
work.
gonna. Oh, okay. Last time I clicked it, it just covered all my screen. I cannot see you guys. Okay, so yeah, let's just give you a feel of what it can do. And you can see, well, the plot is done in Google Sheet. Okay, basically the result is ported into a spreadsheet, and I have an automation to plot these things using Google Sheet, or I think it can be done in Excel or anything else. Yeah, and I did it this way for simplicity, convenience, and flexibility for tweaking. Okay, so that's an excuse for not having a fancy GUI, right? Okay, so the lane margining tool supports timing voltage margining, retimers, and the hardware. Okay, some hardware has independent error sampler, some don't. And it can do lane parallel, do all lanes on the link in parallel and all links in the system in parallel. Yeah, there's a sample count reporting method. There's the PCI 6 specify two kind of, one's sample rates, one's sample count. I can support both and use that to calculate the bit error rate. And you can see the result. I can do a sweep. Basically, you can start from offset, and you step, you set the step, and you stop at it's a target offset. And there's a variation in this feature to support characterization mode and production mode. And yeah, this is developed based on the PCI utils. And well, I shouldn't say Linux only. Now I just learned that it supports, Microsoft had this library for it. And on top of this C library, I use the Go language as to develop the engine, and then it takes in a protobuf as the test configuration, which I'll show you next slide. And also the result is dumped into a protobuf and or CSV form, and you can import it into a spreadsheet and plot it.
Question from Dan.
One last comment for this slide is that, so this is the engine's library, and on top of that, there's a different executable top layer that calls this engine, which can be used to adapt into different scenario. Like either we previously have some production testing toolchain that use a Go layer. I have a layer for that, And recently I kind of integrate this one into the I don't know if Melton is a generic term that uses.
We call it OCP Diag 2.0 or
Okay, all right.
1.0 for Melton. Sorry.
Okay, OCP. Okay. Yeah, and those. So that's the feature support. Okay, the question. Yes.
So done. Then
yeah.
just 1 second. We'll take these two questions from Dan and Rajat, and then I see Michael is on the call, so we might put a small break on this one.
Sure
Go,
thing. Well, one of the questions I had was your voltage margining. I actually did not know that that was capable. I knew of the timing exposure. I didn't know that the voltage was. Is that like the DC offset margining that you're doing, or is that like amplitude margining that you're doing?
It's the amplitude. It's the eye diagram. The vertical axis of the
height of the eye. Then
height of the eye. Yes.
Okay, got it. Thank you.
Yeah, that's optional in PCIe 4. Yeah, PCIe 4, but required on PCIe 5. Yeah. Okay.
Rajat?
Sorry, very fundamental question. So all of these margining parameters are configuration space in the PCI Express space. Is that right?
Yes. I can show you an example of my input output. I have 2 more slides after this to show you how you configure the test parameters and what the result looks like. Should I finish, or we want to take a break to someone join?
Yeah. So do you mind if we take like a minute or two to get back to the discussion with the summit? Leave the presentation as is. I'm gonna pause the recording for a sec.
Okay.
Okay, thanks.
Okay. I have two more slides, basically just show you an example of the test input and the result. Those are in the protobuf format. So this is how you specify a test. And there are 2 examples here. On the left is in characterization testing spec. Basically, you can specify, okay, you can have multiple these specs in the protobuf, and it will conduct all of them. One test spec is, per voltage or per timing margin, and you specify a receiver. So, oops, how do I go back? Okay. Yeah, you can see receiver upstream port or retimer downstream port. You give it a sample count. Basically, the LMR spec has like this is conversion, the actual number of bits sampled. It does a logarithmic conversion to a sample count. The range is from 0 to 127. Okay, roughly it actually translates to this formula. Okay, so basically, say 110 translates to 10 to the 11th samples bits. Okay, we can specify a minimum dwell time. So between the samples and the dwell time, it will use the larger of the 2. Okay, and you can set error limit, which if it goes over, the test will fail. This is kind of a pass-fail criteria in production use.
Well, quick question about your error limit. Is that a mask violation, or is that a PCIe error that you're counting there?
These are supposedly okay. The concept is that, okay, you train the PCI link, okay, you're supposed to you sample the data at the eye center, okay, directly, okay, and that's your assumed correct data, okay. We want to see how good the signal quality is, so we move the sampling away from that calibrated trained center and sample that data at the same time and compare with the data you sample at the trained data center.
Okay, got it. It's
Okay,
a
the eye center. So, and then you compare whether it's the same or different.
Okay,
so if
thank
it's
you.
different, that's an error. Yeah. Okay. So, and in the lab environment, say you specify a starting offset and you specify a step. It will just from the start and go out. And you can specify a target offset. That's where it's gonna end. Or if you don't specify that, it'll just go outwards until both sides fail the error limit. Okay, and you can specify a lane number, so you don't have to do the entire link, all the lanes on the link. Okay, in the production case, it's simpler. Basically, you just give it a target offset. It'll just try to margin at that point, and for that dwell time number of bits, and then see whether you get more errors than your error limit. The result is put into the same protobuf kind of template. This is the lane margining parameter that extracted from the hardware, the file, that what kind of lane margining support you get from the hardware. These are all specified in the PCI 6 spec. And the result per offset, okay, you get the direction. Okay, there's timing margin, there's voltage margin result. There's a direction left, right, or up, down, and where the offset is, and the status, whether you have more errors than your error limit or it's continuing margin. So that's the feature that unless you stop it, is just keep on doing the sampling. And the actual sample count done in this run, or the sample count at the point of fitting the error count.
Question from Leland.
This can be calculated from either the sample rate or it reported by the hardware if it has a counter. And then based on the lane parameter, we can calculate the actual percentage UI or the voltage. That's the result. And from that, you can plot these things. Okay.
You have a question from Leland.
Just one more comment responding to earlier question is that this tool, at one point I did build it outside of our Google environment and send it to a vendor to troubleshoot their lane margining hardware problem. They're able to run it on their end to fix their hardware problem. And yeah, but that was released under the NDA with the vendor. So yeah, my understanding is it itself can be open source, but going through the open source process is something I don't want to go through. Okay, yeah. Question.
Yeah, I think both of this, your tool and the tool our company develop, do the same thing and step by step doing the voltage and the timing margin. One question for you is that do you overstep if you reach the limit? Let's say for particular line. Let's say for the system you have 1,000 lines, right? So if you set the error limit at a 10, at step number 2, one line hit that error limit number 10, do you skip that line or will you continue move the steps away from that line to the margin?
Okay. So let me see if I understand the question correctly. Okay, so this one is, say, let's just focusing on one lane, right? One lane. If you it's I think it's related to the start, step, and target. Okay. So if you're talking about sweeping, so you do start with the start offset, and then you step out. Okay. If you specify a target offset, it will have to go until you reach that target offset. That can be a problem if there's no independent error sampler. That can be a problem.
Yeah.
If you don't specify the target offset, then it will just reach the error limit on both sides. Okay, and it will stop. It doesn't go beyond
the other lanes, because on the system we are doing 1,000 line sweep, right? Doing all the time at the same time.
Well, this is per lane. You're doing.
So for the core you don't do.
No. So basically you do one test back, and this is applied to each lane individually.
Oh, okay.
So you can see, okay, in this case, let me go back to this. You can see per lane actually stop at different point until you hit the arrow. The red thing is like you error out, right?
So this is still per lane scan. It's not per system scan.
This is you do all the lanes in the system in parallel.
Oh, that's mean.
Okay, because you let the lane margin run, and so for example, okay, at Gen 5 speed, okay, if you want to get 10 to the 12 samples, that takes 30 seconds if you sample every bit. So you have to do it in parallel.
Yeah.
Okay, and otherwise it will run forever. So so you do all the lanes in parallel, and each lane it will stop when you hit the error limit on both sides.
Oh, so your test spec is a per lane specified.
Well, it's one spec, and the spec is applied to each lane individually.
Okay. Yeah. Got it. Thanks.
So we are on time, or at least 1 minute off. I think we might have more questions about this. Well, will you be available next week as well if we are to continue this discussion?
Sure. Yeah. Hopefully, I can talk to Satish. We're from the same group before.
Yeah, he definitely wants a chance to present too. He was bummed that the timing didn't work out. I've got to run, folks. Thanks everybody today.
All right. Thank you.
Bye-bye. Okay. We'll see you next week. Thanks, everyone.
Cheers. Thanks, guys.
Oh, can we have slides?
I'll let Dan share it.
All right. Thanks.
Yeah.